Hi there and welcome to this video for Senior Physics on Light and Waves. In this video we're going to explore the idea of wave boundaries. Now basically wave boundaries look at what happens when a wave actually hits an object. Now you can see here in the diagram we've got a wave which is generated by a slinky. Now that slinky could be water waves, or it could be sound waves, or it could even be light waves. Now what happens when it hits a solid object, basically an object that is immovable? The result is that it's going to generate a reflected wave. Just like we saw when we looked at light hitting a mirror. The light comes along, it hits the mirror, it can't get through it, and it bounces back off. Well, in this case, the wave does the same thing. And I suppose in this respect, it actually gives us the idea that light can travel in the form of waves because it can bounce straight off an object. Okay, so now what we do notice is that when an incident wave comes as a single wave along our slinky, when it is reflected off, it is inverted, i.e. it is upside down. Now that's really important for our next unit when we look at superpositioning, because sometimes when we have a continuous wave or continuous waves, where we've got waves continually coming along and then hitting, the reflected wave will have an effect of interacting with the wave coming in, or the incident wave, and they are going to combine together in a specific way. So to recap, when a wave hits a solid boundary that is immovable, its reflected wave is sent back and it is inverted. We state that it's 180 degrees out of phase. Now if you think about the wave as a sine wave, you've got your top portion being the positive and the bottom portion being the negative. So as a result, in a circle, the top portion is 180 degrees, the bottom portion is 180 degrees, which gives you 360 degrees, which means that because we're 180 degrees out of phase, what was once on top has now been flipped and now is inverted. So 100 degrees out of phase is what we call it. Now the question then is, well, what happens if it hits an object which is not immovable? It actually has some fluidity with it. So in this situation, we've got something where we've got one type of spring going into another type of spring. In this case, we've got a light spring going into a heavier spring. Now what we find is that when the incident wave comes along from the lighter spring and hits the boundary surface, some of the energy which is generated by the wave is passed through the heavier spring. But instead of being inverted, it carries on in its normal path. However, the light spring then has the reflected wave, which is actually bouncing off the heavy spring which has been generated. It's almost as if the boundary is almost forming some form of very tough surface that it can't get through. So some of that energy is passed through the spring, some of the energy is going to be passed back. That passes back is actually inverted in this case. Now, what would make a lot of sense is the fact that the energy of passing through the heavy spring and the energy in the reflected wave on the lighter spring should add up to the total amount of energy that we've got inside the light spring in its incident form. So what we notice is that when a spring hits a heavier spring, the reflected ray that passes, or wave that passes through the light spring, is inverted, but also some of the wave is actually passed through the heavy spring itself. So what happens if we turn them around? What happens if we have a heavy spring meeting a lighter spring? Well, here's an example that we've got here. So here we've got the heavier spring going and meeting a lighter spring. We've got our incident wave coming through. And again, what we notice here is that we are going to get no inversion whatsoever. The wave will pass through the lighter spring, but there will also be some reflection from that lighter spring. Now this is actually very difficult to demonstrate. You need to have springs which work quite nicely together and can join quite nicely together. Hence that's why I've used diagrams in this scenario. So to recap what happens, we've got an incident wave hitting an immovable object. The reflected wave is going to be inverted, passing back in the opposite direction. If we've got a light spring hitting a heavier spring, the incident wave, hits at the boundary surface. Some of the wave is inverted and passes back through the lighter spring. Some of the wave remains in its normal state and passes through the heavy spring. And finally, if we've got a wave passing through a heavy spring going into a lighter spring, what we notice is that some of the wave energy is passed through the lighter spring, but it's the correct way up, and some of the wave is passed back through the heavy spring, and that is also the correct way up, as we can see here in the final diagram. Okay, well, I hope that makes sense. I look forward to you joining me again, and we'll be talking about wave superpositioning, which sort of incorporates what happens when we deal with incident waves meeting reflected waves, which are inverted. Okay, thanks for watching.